Thank you for your time and interest today. This is a brief recap of a test Walker Process Equipment conducted in conjunction with the DeKalb, Illinois Sanitary District to compare the cost and mixing efficiency of two different anaerobic digester mixing systems operated in parallel for over 2 years. This report was first presented at the Iowa Annual Conference in 2015. If you're watching this, it is because you have an interest in finding the best mixing system for your digester. As you know, there are a lot of published tests on this subject. This slide represents one by an independent consulting engineer comparing only initial and operating costs. Notice that the first two traditional approaches are both high in initial and operating energy costs. The last two are both much less expensive initially, but differ substantially in their ongoing energy cost. This test adds a fifth mixing cycle to the alternates and compares cost as well as digester mixing efficiency. This is a snapshot of the DeKalb, Illinois water treatment plant. Our sincere thanks go to the operators and management of the district in their generous cooperation in conducting the test. What follows are some results of that test. A key benefit provided by the DeKalb district's plant was the opportunity to directly compare two digester trains, identical except for the mixing systems used. The existing mixing system is a vortex type supplied by JetMix. A vertical-mounted mechanical agitator was the test mixing system. While installed in over 500 digesters worldwide, Walker Process is introducing this European-proven product in the United States and adds U.S. standard components, controls, and local support for the life of the installation. Study of these comparable CFDs shows one key difference in the two test mixing systems. The Walker Stamo mechanical agitator is designed for very gentle vertical flow patterns of digester contents. The JetMix system is implied to have about 15 times the average fluid velocity, one reason for its inherently greater cost and energy consumption. Here is a summary of the overall test protocol. What follows are summaries of the analytical test results. You may wish to pause the video here to study this graph of the distribution of volatile suspended solids in each digester from top to bottom at the 3 sample locations. A consistent trend in the JetMix-equipped digester was a high solids, often dry solid crust above the digester sludge surface and the appearance of high solids sludge layers up to 5 to 10 feet below the sludge surface before mixing the VSS became uniform. The Walker Stamo mechanical agitator provided very uniform solids distribution throughout the digester once below the surface. The next slide averages the data further. Here are the averages of over 1,000 samples from each digester over a 1-year period, again showing the difference in and improvement of solids distribution from the Walker Stamo mechanical agitator over the JetMix system. A second parameter measured in the test was sample density, again showing the differences in the mixing uniformity between the two mixing systems. Finally, the next 2 slides show sample temperature measured for the digester samples, first on this slide for fall-winter operation, and the same plots for spring-summer operation. In all cases, sample temperature uniformity was improved in the digester mixed with the Walker Stamo agitator. One benefit from better mixing in a digester should be the generation of more digester gas production. The installation of mass flow meters in both digesters' gas lines allowed us to compile total digester gas generation for the 11-month period. A measurable increase in gas was generated from the Walker Stamo mixing system. Incidentally, this trend of up to 10% more digester gas from the Walker Stamo mix system has continued for another full year's operation. Improved digester solids distribution, more uniform digester temperature, up to 10% more digester gas generation. These are all important differences. How about the cost to operate the different mixing systems? 50 horsepower to drive the jet mix system, 3 horsepower to drive the Walker-Stamo agitator. The extreme difference in operating energy cost is apparent. The DeKalb Sanitary District provided some of these capital cost estimates. Walker believes the initial cost savings the Walker-Stamo system provides are conservatively estimated here. Here are the final conclusions from this test. The DSD conclusions are provided by the DeKalb Sanitary District. Walker Process has since provided additional installations of the Stamo agitators to add to the 500 worldwide working installations here in the U.S. We hope to have the opportunity to work with you and your organization in the future. So now back to the original consulting engineer's mixer comparison. We have taken the liberty of adding a 5th digester mixing system to the 4 the consultant studied, and noted that this test supports the conclusion that the Walker-Stamo agitator provides for both the lowest initial and operating cost option of all. Thank you again for your time and interest. Please feel free to contact Walker Process Equipment for more information about this exciting alternative to anaerobic digester mixing.